All right, I'm sure you've heard that song. This is the song that never ends. This is the problem that never ends. I think there's like M or N parts. So let's go ahead and get started. Is the width of a tornado related to the amount of distance for which the tornado is on the ground? The accompanying data represent the width in yards and length in miles of tornadoes in a particular region for one calendar year. Complete parts A through N now. So first of all, what is the explanatory variable? Well, it sounds like they believe the width affects the distance that the tornado travels on the ground. And so the width would be the explanatory variable. Explain why this data should be analyzed as bivariate quantitative data. For each tornado, two quantitative variables are measured. Right, we do have two. It's the width and the length. So width and length. That's what makes it bivariate. Draw a scatter diagram of the data. What type of relation appears to exist? Well, let's go ahead and do that. So we need to go to StatCrunch. And stat, regression, simple linear. Select our variable. So we have yards are basically acting like x, and length is our y variable. Let's go ahead and compute. Now I'm going to go ahead and write down the regression line while we're here. So it's y equals, now remember the width is basically acting like it's our independent variable which acts like x, and so it's 0.0098. So actually that'll be 0.010 if we round to two decimal places, or three decimal places. And then it'll be plus 0.342. That would be our y-intercept. All right, let's go ahead and look at the graph. And you can see we have some extreme values here and here. And let me make this a little smaller. And hopefully we can figure out which graph we're looking at here. Okay, so let's go to the right here. This one only has 1 point there. Let's look for the one that has 2. I think it looked a little different than that. So this one's a possibility. Actually, this one looks like it might be the one. Yeah, I think we're looking at B here. All right, let's see. Let's see, it looks like it's a positive linear relationship, although most of our points are down here. So a positive relationship between width and the length of a tornado. All right. Determine the correlation coefficient. Oh, and I didn't write that one down. Let me go ahead and grab that. Whoops. Let's make that a little bigger. So R was 0.7898. So to 3 decimal places, that would be 0.790. And R squared, I'm going to go ahead and write that down just in case we need that. All right, so let's go ahead and put in our correlation coefficient of 0.790. Is there a linear relation between a tornado's width and its length on the ground? Now, I don't see that they gave us a chance to look for, oh, I can't remember the name of it, the critical value. So I'm going to say yes, just based on what we've done before. That seems high enough. Let's continue. Find the least squares regression line. So notice it says round to 3 decimal places. So it would be 0.010x and 0.342 for the intercept. Let's go ahead, predict the length of a tornado whose width is 300 yards. So this is basically, this least squares regression line is our predictor. Gives us the predicted value. And so we're going to plug in 300 for x since that's a width. So let me go ahead and do that. So it's 0.010 times 300 plus 0.342. I guess I can show you what I'm doing here. Let me focus that a little better. So let's go ahead and plug in the numbers here. So 0.01 times 300 plus 0.342, and we get 3.342. All right, let's go back. So predict the length of a tornado whose width is 300 yards. Notice it says to 1 decimal place, so I got 3.342, so it'll be 3.3 miles. All right. Was the tornado whose width is 830 yards and length was 5.2 miles on the ground longer than would be expected? Well, again, what's expected would be predicted by our line. So this time I've got to plug in 830 into my equation. So again, I'll show you what I'm doing here. So this time we're using 830. So 0.01 times 830 plus 0.342. And I'm getting 8.642. So we would predict, our prediction would say it's going to be about 8.6 miles. So what did it actually come out to? 5.2. So I would say no. The predicted length of a tornado with width 830 yards is 8.6 miles. So 5.2 miles is less than expected. All right. Interpret the slope. Let's see. So I'm going to go back to my work here. So this is the regression line. So our slope is 0.010 over 1. And remember, this is width in yards. Or was it yards? Hold on a second, I need to check. Yeah, it's in yards. And then we know that the bottom is the length. Let's see, the length of tornadoes, length in miles. So let me go back to my work on paper. So you want to write your slope with a rise and a run. Now remember, it's basically the change in y over the change in x. So for oh, you know what? I've got this upside down. This is not right. Because remember, the numerator is your change in y, the denominator is your change in x. So this would be your width in yards, and the numerator would be your length in miles. So for every 1 yard that the width changes, the number of miles is going to change by 1/100th of a mile. So let's see if we can find that response. So for each mile increase in tornado oh boy, let me see if I got this right. For each mile increase in tornado width, the tornado I said that wrong. So it is for each, because we said our denominator was the width, which was in yards. So for each yard increase in tornado width, the tornado length increases by, and it was 0.01 or 1/100th on average. Well, and actually they went to 3 decimal places. All right. Explain why it does not make sense to interpret the intercept. Select the correct choice below. Well, let's go back and look at the intercept. Remember, W, or you can think of this as your X variable, your independent variable. The width can't be 0. That doesn't make any sense that you're going to talk about a tornado that has a width of 0. And so let's go back and see if we can find something along those lines. The width of the tornado cannot be 0 yards. That's going to be the one. Whoops. So there we go. What proportion of the variability in tornado length is explained by the width of the tornado? Now remember, I did write down r squared, and r squared was 0.6238. It'd be 62.38% of the data would be explained by the width of the tornado. It does say round to 1 decimal place, so it'll be 62.4%. Let's check our answer. So plot residuals against the width. Does the residual plot suggest the two variables are linear related? Okay, so let's go ahead and, oh boy, let's see if we can get back. So we want to plot the residuals. See if I can remember how to do this. Oh boy, I think I have to start all over again. It looks like I messed up. Okay, so let's go ahead and just go to the data, go to StatCrunch. We're going to actually do things a little bit differently here. So we want to go to, again, regression, simple linear, and we'll select the same. So our width is our x variable, our independent variable, our length is the dependent variable. The thing we're going to choose differently, though, is we want to choose residuals versus x values. The other thing is I actually want to put these into the spreadsheet, so we want to save the residuals, so let's go ahead and compute. And so here's our graph. You can see you got some extreme values here and here. Just trying to figure out how to identify this. Let's go ahead and click on here. See if we can figure out which graph this is. Now I can go back and put my graph in, although I'm going to have to make this smaller. Okay, so it looks like, let's see if we can figure this out. It's not that one, because you can see we've got a couple of values here and then a couple up here. Looks like it might be C. Let's look at C. Yeah, C is looking pretty good. What about D? No, it looks like it's going to be C. So let me just check one more time. Yeah, I'm going to say it's this one here, this C. So for me, that's one thing you got to really look at closely, the different points, enough points to figure out which one's which. Okay, so plot residuals against the width. Oh, let's see, we did that. So the residual plot suggests that the two variables are likely well, let's see. Don't really have any discernible pattern here, so we can, like this is definitely interesting linear pattern. And so because there's no particular pattern here, when we plot the residuals, we would say that they're likely linear related. Draw a box plot of the residuals. Are there any outliers? All right, so here's how we do that. We're going to go back to, let's see if I can get back here to our graph here. And we can click out of here. We actually are interested in the residuals here. So we're going to do a box plot. That's a graph. Box plot. And we're doing residuals. And you want to click on draw boxes horizontally. And use fences to identify outliers. I think that's all we need to do there. So there's your box plot. And you can see you've definitely got some outliers here. It looks like you have 4 on each side, or 5 on the right. 5 on the right, 4 on the left. So if we can figure out which one's the right one here. Well, that's interesting. Let's go back to our graph. It looks like it's more, data's more spread out on the right. Let's go back to our graphs. This is the only one that really seems to show outliers. I'm not sure why it's not showing as many, but I'm going to go with A here. All right, there exists at least one outlier. All right, so it says a major tornado was 4,556 yards wide that had a length of 21.3 miles. Is this an influential tornado? Explain. Select the correct choice below, and if necessary, fill in any answer boxes to complete your choice. So we're going to have to put that point in, so let me write it down. It's 4,556 and 21.3 miles, so let's go back here. And put that point in. So 4,556, 21.3, and let's go ahead and look for the regression line. So regression, simple linear. So we want to select the width and the length, and let's go ahead and compute. Make this a little bigger, so let me go ahead and write this line. It's y equals, it's going to be 0.006 times the width plus 1.280. So if you look at, I'll go ahead and show you what I'm looking at here. So with this additional point, notice definitely the y-intercept changes by a bunch, and notice the slope decreases by probably a significant amount, because this is 10 thousandths and now we're at 6 thousandths. So let's go back and see what our options are. Is this an influential tornado? I would say yes. So let's go ahead and click here. The slope changes to 0.006 and the intercept changes to 1.280. All right, and so we have made it through number 7. All right, that's going to be it for this video.